Okay, factoring polynomials. We went over this Thursday in class, the November the 8th, I believe. And I gave a homework out, and it seems like you guys had some questions on it. So let me just record, what the notes were, and maybe you can go back and see some of those. Now, first off, let me just point out the first 4 questions on the homework I gave you is just factoring review stuff. So that's just old school factoring, GCF method or difference of squares method, and product and sum method. You just got to go back to your factoring review notes or check out the factoring review video and just factor those. It's not really relevant to the whole well, it's sort of relevant to polynomials thing, but it is more or less a review, those first 4 questions. So I'm just going to cover the new stuff. So starting with, I think, number 5, 6, 7, and 8, those questions, I think will be the first things I talk about in this video, or at least those types of questions, not those specific ones. But I want to remind you that when you do synthetic division or synthetic substitution, which is the same thing, that the a value, or the value that's in the box on the top left, being the x value, the remainder is actually the y value that corresponds with that x value. So let me, I'll give you an example. Let me work one of these out, and I'll explain what I mean after I do one, okay? So this question's asking, is x plus 1 a factor of x squared minus 3x plus 1? So we're going to use synthetic substitution or synthetic division, whichever you want to call it, to help us figure that out. And all that we're really interested in is the remainder. So if I'm going to use my synthetic substitution, my factor x plus 1 that I'm interested in, my a value, or really what I should say is my x value, is -1. Because I'm looking at this as an x-intercept, right? If as x plus 1 equal to 0, which would be an x-intercept, I'm looking at the x value at -1, right? So it's not really this number I'm interested in, it's the x value itself. And that's the a value. It's typically just the opposite of this, of that 1. But it is -1 for that exact reason, because we're looking at it sort of as an x-intercept point, which would be -1. So that's the a value, or x value, as I said. And next to it, we write the coefficients of the polynomial we're dividing by. So we'll put 1 for the 1x squared. I know it doesn't say 1, but there is a 1 there. -3 for the -3x, and then 1 for the plus 1 at the end. And so synthetic substitution, or synthetic division, we always bring down this first term. That's a 1 there, so we're going to bring a 1 down there. Those should always be the same. There's a lot of times people accidentally write the wrong thing there, and it ruins every part of this problem afterwards. So be careful on that. So bring the 1 down, and then multiply that 1 with your a value, or x value, of -1. So 1 times -1 is -1. We're going to take that, we're going to put it underneath the -3. Now we're going to add these together to get my next term. So -3 minus 1, I'm saying adding, but it's really subtracting, I guess, because it is a -1. -3 minus 1 is -4. So again, I take the -4 and I multiply that with my a value, or x value, -1. So -4 times -1 is +4. Put that under the 1, and then add those up to get my next term. So 1 and 4 makes 5. So this is my remainder. My remainder is 5, and that's the only thing I'm interested in. Now, what this means, my a value being really an x value, like x equals -1, as I mentioned earlier. When x is -1, my remainder, this is actually the y value at that x value. So if you were to plug in -1 into this polynomial, plug in -1, -3 times -1 plus 1, it should end up being 5. Okay, so the remainder is the y value that corresponds with that x value. So you'll see this be 1 plus 3 plus 1, and 1 plus 3 plus 1 is 5. So we did it right. So it's kind of neat how that works, how the remainder is actually the y value corresponding with the x value we used up here, that -1 in this case. But to answer this question, is it a factor? It is a factor if the remainder is 0, because if the remainder is 0, for instance, this one's not 0, it's 5. If the remainder is 0, that means the y value is 0, which means it's on the x-axis. And if it's on the x-axis, it's an x-intercept. And if it's an x-intercept, it does count as a factor. X plus 1 would count as a factor. So if the remainder is 0, we're going to say yes, it's a factor. If the remainder is not 0, like it is in this case, the remainder is 5, not 0, we're going to say no, it's not a factor. So in this case, example A is not a factor since the remainder is 5 instead of 0. But let's look at example 2. To set it up, I'm looking at the x value or a value that's opposite of 2, so it's -2 in this case. So remember, this is x equals -2 or a, whatever. And then we're going to write the coefficients for the polynomial. So we have 3 for 3x to the 4th, 6 for 6x to the 3rd, 0, because notice this is for my x squared term. There is no x squared term. So that's why there's 0 to fill in for the x squared term. And then -5 for -5x and -10 for -10. So when I solve this, I'm really just looking for this remainder. So let's solve this. We bring the first term down, that's 3. Okay, now we multiply that with a. 3 times -2 is -6. We put that under the next term. We add these to get the next value that I multiply with a. So 6 minus 6 is 0. So I take 0 and I multiply it with -2. 0 times -2 is 0. Put that under the next term. Add these up. 0 plus 0 is still 0. Again, multiply that number now with the a. 0 times -2 is still 0. Put that under the next term. Add these. -5 plus 0 is -5. And now again, multiply the -5 with the -2, which makes it +10. And -10 plus 10 ends up being 0. So the remainder is 0. So that means I have the point -2, 0. Confirmed. Now, because the remainder is 0, this is an x-intercept, which means, yes, x plus 2 is a factor. So this first one was no, it's not a factor, but this one is yes, it is. So remember, all you're looking at is the remainder. If the remainder is 0, like it is in this case, it's yes. If it's not 0, it's not a factor, it would be no. That's more or less just what those are. So I think that explains it enough. Just to keep the video short and sweet, I will sort of skip ahead a little bit. Nope. All right, so factor by grouping. So this is like number 9 and 10, I think, on the homework I gave you. You've got 4 terms. When you have 4 terms, you always factor by grouping. So you group the first 2 terms together, and you group the last 2 terms together, and then you just factor each group by GCF. So the first group, both of these terms have an x squared in common. Now, the first term has x to the 3rd, so it's got an extra x. But in terms of what these 2 terms have in common, they each have at least an x squared. So I'm going to factor an x squared out. And so that leaves me an x squared canceling out with 2 of those x's, leaves me with 1 x left. These x squareds cancel, leaves me with +2. Now here, there's not really a GCF, but if this term is negative, you're going to factor out a negative. So let's go ahead and divide out a -1. Bring that -1 out, and that'll leave me a positive x and a +2, which is what I want because my 2 binomials here are supposed to match. So notice they're both x plus 2. So my factors, I have x plus 2 because that's the common factor they have, and then x squared minus 1 because that is obviously the outside part, the GCF part. Now that's good, and you might think you're done. However, you have to pay close attention to the fact that x squared minus 1 is still factorable. That is factorable using difference of squares, right? X squared is x and x, and -1 is 1 and -1. So you can actually factor that into x plus 1 and x minus 1. So that x squared minus 1 factors into x plus 1, x minus 1 by difference of squares. Now notice the x plus 2, that's factored already. There's nothing to factor about it, but it's still here. It's still a part of my answer. So don't forget to bring it down. So my final answer is those 3 groups. It's x plus 2, x plus 1, and x minus 1. Now, it doesn't matter, by the way, the order of these 3. You could have those 3 polynomials in any order. It's still the same thing. As long as you have them 3, you're all good. So we'll do one more factor by grouping. Just get the point, drill it home. So remember, factor by grouping, group the first 2 terms together, group the last 2 terms together, and factor GCF. So the first group has an x squared in common, so I'm going to factor x squared out. That leaves me with x minus 1. So even though the x squared cancels here, you still have a 1 there. Now, obviously, these both have 25 in common, but again, since this term, the first term in the second group, that's negative, I'm going to factor out negative 25 instead of a positive 25. So I'm factoring out a negative 25, which leaves me a positive x, and then again, a negative 1, which matches because, of course, x minus 1, those two binomials need to be the same. So my factors will be x minus 1, since that's the common binomial, and then x squared minus 25. But just like the last problem, this is still factorable by difference of squares. X times x, 5 times 5. So together that makes x plus 5 and x minus 5 as my factors. And don't forget to bring down the x minus 1. So there's your answer, x minus 1, x plus 5, x minus 5. And then what was the last part? The last part was our new factoring method. I'm going to leave that up there if you want to look at it, but that's just another example. But we had the sum and difference of cubes. Again, I guess I'll leave this one up there too if you want to see it. This one's different because the plus 4. Plus means it's not difference of squares, so you can't factor that anymore. So that would be your final answer. You can't change it. So be on the lookout for that. So basically, sum of 2 cubes, difference of 2 cubes is basically a formula. This is the formula. So this is what sum of cubes means. It means you're taking 2 cubes and adding them together. So that's kind of what the problem will look like. And the factored version of it is what I've kind of rectangled there, okay? Basically, kind of think of it as a formula. So difference of cubes is basically the same thing. Just notice a slight difference between the plus and minus signs. Obviously, that stayed the same, but these first two switched. So we'll come back to them, but you might want to write them down unless you want to keep rewinding the video or just memorize them, which would be better as well. But let's go ahead and explain this. It's not very tricky, but you just have to know your cube roots and you have to know these formulas and plugging things in. It's pretty simple. So first, let me write down the perfect cubes. We wrote this on the board the other day, but we'll write it down again here. So give me a second to write them all down. You could probably just fast forward a little bit and skip this part if you want to. But then you're going to miss all the fun jokes. So, if you're here watching this with me, knock, knock. Who's there? No one, because I'm by myself. But it's true, though. It's true. It's 8. 3 to the third is 27. 4 to the third is 64. I just made that joke up, by the way. I thought it was pretty good. All right. So basically, that's a cheat sheet, what I just wrote there. So now look at this example here. Now, first and foremost, there are no cubes in this, obviously. All my cubes, as I just pointed out, and I'll underline, all my cubes, x to the third, x to the 6, x to the 9th, x to 12, those are cubes. 1, 8, 27, 64, 125. Those are cubes. And I'm looking at 4 and 108 and all those x's, and I'm not seeing any of those on my number list here. That's because you need to factor this by GCF first. That has a factor of 4x. You could factor the 4x out of this and worry about that later. So factor 4x out leaves you with an x to the third plus 27. 108 divided by 4 is 27. So the 4x factored out. So ignore that for now. It's still there. It's relevant. But now, what I really want to bring you to your attention is x to the third plus 27. This is a sum of cubes. I'm adding 2 perfect cubes. X to the third is a perfect cube, and 27 is a perfect cube. So our sum of cubes formula was a plus b, a squared minus ab plus b squared. So all we really need to do is figure out what the a is and what the b is and plug them in. Now, a and b are both the cube root of those things. Now, with the cube root, and again, back to our cheat sheet, if you look at your x to the third, the cube root of that is just a plain x, right? A plain x to the third power is what makes x to the third, but a plain x nonetheless. That's why I put it in parentheses. So my a, quote unquote, so to speak, will be x. So I'll plug x in where I plug in a. My b is the cube root of 27. Now, the cube root of 27 is 3, because 3 to the third power makes 27. So that'll act as my b value. So I'm going to plug in x for a. I'm going to plug in 3 for b. So that'll be x squared minus x times 3, but x times 3 will be 3x. And then b squared. Now, b is 3, remember, but 3 squared is going to be 9. So if you want to write that down, b is 3, but when I square 3, 3 squared is 9. And don't forget, so that's how x minus x to the third plus 27 factors into this. But don't forget the 4x was still chilling out here. So as far as the final answer goes, you do have 4x on the outside and then that. So it's just the formula. It's just something you want to plug in. You want to know that formula, but also you want to use this cheat sheet. So write this cheat sheet down. I'm not going to write it down again, but I'll reference it in one more example. We'll do one more example. Yeah, so we'll do this one. Now notice in this one, I've got a difference of cubes. 125, 8, and this d to the third, or in my cheat sheet, I had x to the third. But either way, all of those are perfect cubes. Let me go back, I guess, and reference that real quick. So what was it? We had 125, we had x to the third, or d to the third, and we had 8. So notice how all those are perfect cubes. Now, you might want to pay attention to what the cube roots of them are. 125 is 5, 8 is 2, and x to the third, or d to the third, which is x, or just d. So as far as a and b go, well, let me write down the formula. I know it's difference of cubes since it's minus. So difference of cubes is a minus b, and then a squared plus ab plus b squared. But a comes from the cube root of 125d to the third. So 125, the cube root of 125 is 5. And the cube root of d to the third is just d, right? Just like x to the third in the last example was just x. D to the third, its cube root is just d. So 5d is going to act as a. So I'm going to plug in 5d wherever I see a. Now b, the cube root of 8. So the cube root of 8 comes from 3, or not 3, 2, because 2 to the third power was 8, and that's back on our cheat sheet. So 2 is going to act as our b value. So everywhere I see b, I'm going to put 2. Now you need to be careful here because we are squaring. When I square a, and 5d is a, I'm squaring not just d here, but 5d. I'm squaring both of them. And I'm going to write them in parentheses. I'll write it simplified in the next line. But I do want to point out that you're squaring 5d collectively, not just it's. You'll see what I mean. A times b, that's obviously 5d times 2, because that's a and that's b, plus b squared. So b again was 2, so it's going to be 2 squared. I'm going to simplify these all in the next and final sentence here. So 5d minus 2, obviously there's nothing changed there. But 5d squared, what I was saying earlier, is I'm squaring not just d, so it's not 5d to the second power. That's not where you're going to write. You're going to write 25d to the second power, because you have to remember you're squaring not only d, but 5. So square the 5, and you get 25. Square the d, and you get d to the second. 5d times 2, well, 5 times 2 is 10, so it'll just be 10d. And then 2 to the second power is 4. So this is the simplified version. But pay close attention to this 25. Most people would forget to write that as 25. Most people would write just 5d to the second power. They wouldn't write 5 or 25d to the second power. So be very mindful of that. That's going to cover it, so I'll leave you guys to it. Hopefully I didn't drag this video on too long. All right. Have a good day. Thanksgiving's coming up. Have a good Thanksgiving, and I'll see you later. Bye.